Let me take you on a little adventure into Stario internals. Let's do it based on one of our template projects. So let's just start it up. Let's use UV, Stario init, and let's select tiles. So this is the default project. It's fairly small in scope, but it will show us really a lot of things that are happening in Stario and basically explain the whole philosophy behind it. So let's go Stario tiles. Let's see if it's working. So we see requests coming in, that's good. Let's see if they are actually recorded. Looks good. Perfect. So let's close it up and let's just try to open the project. So let's take a look at project structure. It's fairly straightforward. It's a usual Python application structure, like Python package. So we have PyProject TOML file with all the dependencies and information. This is what UV generates, some UV related stuff. And we have our two main things that we need for our project. So we have our static directory here with some CSS styles, and we have Datastar library also here. Let's go into our single file, the main.py, and let's take a look at what's inside. So I'm gonna scroll all the way down here. And right from the start, this is something that I want to highlight here, is Stario tries to do everything as explicitly as possible. So what I mean by that is that I try to make as much as possible just as Python would, like as any other Python script would do. So as any other Python application would do. So there is no like separate way of starting up the application. There is no magical way of configuring it. There is no magical way of providing some dependencies, etc. So everything is just Python code. If you know Python, you'll know what is going on, and you can just easily follow up all the references and see where the data comes from, where the configuration comes from. So I'm highlighting it here because you probably noticed that we can just run this script. We can just run the main.py file, and it will run our main application. So it will run our main function, that is an async function, and it will set up the application and then serve it here. So let's take a quick look at what is actually happening here. So we have really simple, just for the showcase purposes, really simple setup for our like development setup and the production setup that we might want to use when we actually release the application somewhere else, not just locally. So the key difference here is not just in like the host variable, but also in the tracer that we use. So this is maybe a good moment to kind of highlight general idea behind what a tracer is and how it should be understood, because the name relates to OpenTelemetry tracers. This is where I got couple of good like ideas and inspirations, and I think the core of it is kind of the same, but it's also important to remember that Stario is meant to be like a much not maybe smaller, but like thinking things like as a single server. So we don't really care here explicitly about all the traceability between different services, or like in a distributed system. This is just a single server. And although you can extend and write a custom tracer and probably enhance it with the functionality that you might want to have with microservices, primarily we focus on the single server solution, because in 95% of cases that will be everything that you actually need and to set up the application, host the solution, host the app. So we have two different tracers out of the box. So we have RichTracer, and this is mostly primarily used for local development, because this is basically what you see here on the right side. So we have rich, colorful logging that tries to like show you as much as possible of what is happening within the request itself. So this is also like important to kind of distinguish that if you probably can relate in other frameworks like FastAPI or Sonic or anything else, when you have logging, in most cases you use the standard Python logging or maybe some additional libraries for like contextual logging, etc. But in the console itself, you'll see like separate entries right under each other. So what I try to do here is kind of flip it a little bit and focus on how I mostly was investigating issues, like where they occurred and what context I needed for debugging them. And it all boiled down to the request context. So that's why I'm grouping everything that is happening within the context, within this concept of a span. So this is the concept from OpenTelemetry, and whatever happens there is grouped, and we can just view it as a single panel here. Similarly, if we think about JsonTracer, this is like the same information will be logged, but in a JSON format. So more like machine friendly, or like the Grafana or other visualization tools friendly. And it's just a different output. It's like internally, the classes, the objects, the information that you can do is the same. It's just like the output, the sync of the telemetry that you can plug and play with different things. So theoretically, if you wanted, you can just write your own custom one, log it to SQLite or like directly to database or whatever you actually need. And the really nice thing is, although maybe a little bit like too explicit, is that with the tracer, we follow this context manager interface. So you are pretty much guaranteed that when you start the application, it will run the enter method, and when it exits, you have a assurance of clean shutdown. So that's also really nice if you want to like buffer some stuff, if you want to have some like ensured flashing of the all information before you close the whole application itself. So that's pretty neat, and maybe for now that should be enough. We'll go into logging and what we can do in more detail in a second. So now let's go to the application itself. So the main entry point is the Stario object. This is the main root of the application. This is the main router, and this is the main entry point that like we need to configure at least with Tracer, because per request they will create spans that we can observe and like enhance with our custom information. The second optional attribute is compression, but I think for now the compression is not really that important. By default, Stario follows, so we support Z, STD compression, then broadly, and gzip. This is like the convention we took. This is also, like, broadly speaking, from browser perspective, is like widely supported, so that shouldn't be really an issue during development, and or just overall use is enhanced in this. So we have Stario application. Next, we are mounting the directory that I referenced earlier. So this will allow us to just have those files accessible under the /static route. Stario also took a little bit unconventional, at least like from my experience, a little bit different way of handling static files. So what is actually happening, if you go into more like detail and like look into the implementation or like look into logs, is that when we mount static files, so static directory, we expect it to be fetched as a resource, so like a CSS or JavaScript, rather than like from other frameworks it is possible, rather than serving, for example, static HTML files. So this is an important distinction. So this is more like an asset than a static file or like a static site. And what it also means is that so I decided that we can just fingerprint the URLs. So if you think about, let's maybe take a quick look here. If you look at static files here, we have styles.css and datastar.js files here. And when we are serving them in practice, what is actually happening is that on startup of the application, because they are static, we can just add this fingerprint hash before the extension. So what is actually happening if you are under constant development, when you apply caching to it, you will be ensured that if the content actually changes, the fingerprint will be different, so the URL will be different, so the cache will be invalidated and you'll get the newest version. So that's kind of nice feature and useful in cases where you actually when you constantly develop something and you want to invalidate the cache and you're afraid that redeployment on something will still reference the old files from someone's browser. Especially useful when you're using Tailwind or something else that is constantly refreshing itself. So now let's go into routes. So routes or handlers. We also took a very explicit way of assigning them and attaching them to the application or a router itself. So the way it basically works, we can just specify an HTTP method that we want to subscribe to, the path, and then the handler is provided just as a function. Additionally, that is not really the scope of this video, but additionally you can add separate middlewares, or you can also, I'll be explaining on a different example, how you can provide additional variables or dependency objects into those routes. For example, if you have database connection or something more persistent or something you want to inject into route, but not have it globally available. So that will be a topic of a different video that will go that we'll do separately. So once we add all the routes, all is actually left to do is just to serve the application. And this is a standard async IO compatible server. So you can basically switch it between async IO or run it under UV loop or anything else that supports async protocol. So that's really neat. It's up to you to decide which one you want to use. And it also makes Stario fairly small in terms of the overall library size and stuff it's actually trying to do. Let's go into our handlers and let's actually see how they are built, what is the expected protocol, and why they are the way they are. So let's take a look at our simple home handler. This is the most basic, almost everywhere encounterable handler. So the sole purpose of it is when we open the web page, we just want to load the initial HTML, and this is basically what it's doing. So let's first focus on the function signature itself. So we are expecting async function because we're async first. Maybe I did not really underline it, but we expect to use coroutines everywhere because it will help with the overall waiting on resources, etc., the communication. But we are expecting async function with context as a first argument and a writer as a second argument. What's important, and I hope it will be understandable after we go through all three of our handlers here in this example, is that we don't return anything. And that might be a small difference, but if you'll actually pay attention and go through those examples and kind of try to remember or try to imagine how you would have done them with other frameworks like FastAPI, Starlet, or Sonic, etc., you'll see that this approach gives you a little bit more, maybe not just a little, but much bigger control over what is happening, especially in those unusual scenarios that you have a long connection. So, for example, SSE streaming, or if you want to do something after the connection is handled. So probably Like it's still doable in those other frameworks, but this way should yield much simpler, cleaner, and like more understandable code, and also like will allow to do some other cool stuff that that we'll get into. So let's take a look at the signature in more detail here. So we are expecting two arguments, context and writer. Let's quickly change to the whiteboard. So I'm gonna quickly show you this thing. So this is just a general introduction, general information about what those are about, basically. So we have context as a primary class, and context is just everything that is provided, like request related, let's call it. That might be not the best way to describe it, but this is like what comes with a request into the handler. So we will have the HTTP request object itself. So this is the first argument. And in it, you have everything HTTP related that came into the system. So basically, you can read like headers, query parameters, body of it, etc. So this is like everything that you commonly just read as an argument is there. Then you have a second argument, second parameter. This is a span. So we already talked a little bit about logging, and this is this default request scoped. Sorry, not really request, but like handler scoped span. So you'll get like whatever you attach to this one will be like visible in logs. That's one, but it'll also be like within its scope. So you can add attributes. So like just describe it in a way. So for example, like which user was affected, etc. But you can also log events that happen within that span. So for example, you want to note when a cache miss happened, or like if you want to log that new user was created, whatever you want to do, like within the request, this is where you'll do it. Then we have state. So state is it's a fairly standard, like commonly visible, commonly seen approach. So this is just a dictionary, or like I think it's just a dictionary that you can then generically like describe what kind of arguments it's expecting. But the key idea is that you have this little container that is within the request that you can put the data in, and this is like a request scope. So whenever you see state, you should think about like an authentication middleware or anything related to like some information like per user for this request that might be useful to be provided like somewhere within this handling lifetime. And we have last argument. So we have just a reference to the Stario application itself. Practically speaking, it's not really like useful, but you can still like do some dynamic stuff with it. Like I don't know why would you do it, but you can still like add new routes or like do some dynamic stuff because you have reference to it and it's available. So commonly, as I already kind of outlined, what you'll do with context is you'll read the arguments or like parameters from the request itself. So this will look mostly something like that. So like c.request, c.rec, and then you have all the parameters. We'll go into request details like in different moment, not really now. And then like reading the request body as a JSON, that's also available. Because body is streamed into the request, we have to wait for it. So that's also, this is fairly standard. And like, I don't really think it's like unexpected in any way. But also for the context itself, we have this whole, let's call it convenience layer for logging and observability overall. So this comes from my experience, and it might be like a little bit too opinionated, but this is something I figured that it's working for me fairly nice, is that there should be a way to like easily describe what we're computing and why we're computing it, so that later during debugging it's easier to like follow and find what was actually not working. So we have those convenience methods that if you use C with square brackets, you basically add an attribute. So this is just like a description of what is of the span of this main span that we're dealing with. Or if you use the standard brackets, you are creating a new event that that will have a timestamp, like a separate timestamp, and you can attach additional information to it, like what happened, etc. So the key difference is that the attribute is something that is not really related to when it occurred. So for example, that request is for given user, right? And the events themselves are about a moment in time and possibly like some additional information. So like user joined, user disconnected, user new account created, whatever actually happened. This is mostly useful for like finding out how much time elapsed between certain points in the request handling. So for example, you can find that like rendering takes such amount of time, and then like the DB request happened like half a second later, and you can investigate why it happened, etc. It's also possible to create subspans within this main request span. So the idea is that if you have some operation that is taking longer, you want to actually measure how much time it took, not just the moment it started, but how much time the actual duration of it. You have this c.step span that is creating a new subspan, registering it as a child of like the parent that it's in, and then you basically can follow the same thing. So you can still attach attributes to it, create events in it, etc., etc. So now let's look at writer. Writer is also writer is a really important object, and it's like it's really key to know what is it about, and to understand it well is like 80% of Stario, and everything else will just nicely follow and will be like you'll it's this main centerpiece that everything else is kind of aligned around. So if you have experience with languages like Go, you probably will recognize it. This is basically it. And with some additional enhancements and convenience stuff that I just plugged into like a default behavior. So it's different in a way that we are not in the handler itself, we are not returning a response object. We are, and that response object kind of describes for the framework how to build a response. We are doing it in a different way. We're doing it explicitly. We are doing it like directly from within the handler. So the idea is that the handler, so you as a developer and handler as the implementation of the behavior, should be able to decide at what precise moment it's doing which part of the basically response writing. So as you probably know, HTTP response can be like really broadly divided into the creation of head or like header, so the status code and all the headers, and then you have a response body. And especially if you think about long-lived connections, so like SSE, and we stream a lot of data over time, this is where it's really handy to have this separation that we can, for example, at the very beginning of a handler, we can just write headers, and then over time, just packages of information, just as separate events that would come in and be handled accordingly. So let's quickly go through this core interface and then some convenience methods and how it's actually commonly used, at least from my experience. So we have access to headers, so we can set them and we can read them. That's also like obvious. So the idea is that if you really want, in most cases it's not really necessary, but if you really want, you can define the response manually. So you can set custom headers, so like caching, like vary, whatever you actually want. You can set it, and we will just send it to the user when you call write headers function. You also specify the status code in here. So that's this is basically the moment, like after sending headers, this is the moment when the response started. So it's important to remember that, for example, if you set up the headers for HTML response, you will not be able to then like send yet again headers and then the JSON body or something like that, because then it will cause the malformity of the response itself. So that's really a no-go. So it adds some complexity, like treating it as those separate steps, but also it gives you a lot of flexibility if you actually know what you're doing, and I assume that you will. Then we have write method. So write method is basically, as I mentioned, writing portion of the body, and depending if you're chunking it, if you're streaming it, or if you're sending everything at once, that's like in most cases almost the same thing. And it's just, you specify the moment. At that moment you want to put it into buffer, and it will get sent through TCP to the client. And then we have explicit end method. And what it means is that after that one, we don't expect to be sent anything to the user on this connection ever. Maybe not connection, but from this request itself. So the whole idea is that you can think about it this way, is that if you have a long handler, for example, you want to validate the request and do some magic there and then send a response, you might want to do it like in a different order. So for example, just validate it, send to the user that we are done so they can close the connection. It will be like a really, really fast response, and it'll like nice from the user perspective that you responded really quickly. And after that one, you'll be conducting some kind of, I don't know, database insertions or like checkups or like third-party application calls, whatever you want. So this is this kind of split, so that you can send headers separately, the body separately, and then you can call at any moment that you close a connection, gives you this ability to handle all three of most commonly encountered handler types, let's call it like this, really like seamlessly, like in the same, it's the same approach, it's the same way of thinking and implementing stuff. Now, really, from my experience, what is mostly required to actually provide information for the user are the functions that are also like implemented here as a, like, let's call them common or like util functions. So we can just send the full HTML. So it will send headers, body, and end the request within this one call. So this is like encapsulates everything that is happening here. You maybe not want to return anything, so you just return 204 status code with empty body, and this is also like useful if you want to end the connection early and do something after that. And also there is a third type. So this is w.patch. So this is where this partial updates come in. So this is where we have those long-lived connections that we stream updates over time. And patch is just a convenience method for Datastar that is used to patch HTML elements. So whenever you'll see this one, it's just about updating portion or the whole of the HTML page at that place. There is also context manager that is called Alive, and this is on one end a convenience function, let's call it like this, but also it's really useful if you think about commonly encountered life cycles of the application, or like if you have multiplayer game or like multiplayer application. So what will commonly happen is that if you open a connection, you want to do something like at the beginning, then as long as user is connected, do something like update or like stream some data or maybe like send some signals, whatever. And then once they disconnect, you also want to do something. So usually in the frameworks like FastAPI or Starlet, you would expect to, in certain places, you would be like executing something and then waiting for the cancellation exception or something like that. So just to avoid this kind of mess that in my experience happens if you treat it like an interrupt, here we just explicitly monitor, because we are able with the writer, we just explicitly monitor if the server maybe is shutting down, and then we can just clean up nicely, or the client just disconnected and we should just do something about it. So that's really high level, but also most commonly encountered cases, how to use context and how to use writer. So let's go back to the code and let's actually go through it and see how it works in practice. So as I mentioned, here we have home route, home handler, we have our context and writer, and what we're doing here, we're just generating a unique ID for the user that just logged in, and this C with square brackets is the way that we set an attribute on log on the span. So let's quickly look at here. So we have the span that we get the home page, and here you can see that we added this attribute user ID, and this is like not related to any moment in the request. It's just about knowing that, okay, that user logged in, and like if we had some debugging stuff happening, then we can just quickly look, okay, they actually hit that request and they actually got like 200 response, etc. Let's then go to long-lived request, long-lived handler. This is a subscribe function. Again, context and writer, but this time what we will be doing is a little bit different. So before we go into the HTML itself, I just want to go through routes. But for now, just keep in mind, like the overall logic is the following. We open the page, so we call this home page, so this slash path. That one returns all the, let's call it like a shim of the web page, or like everything that is of the current state. So we will have like the head of the HTML with all the libraries that we should import to render the body, etc. So it will be like get the HTML, render it, load it. That's like the initial state of the whole application, of the whole web page. And then within this HTML, we're using Datastar. So once they are loaded, we want to establish this subscribe connection. This is the long-lived connection, and basically on init, Datastar will call this one, and whenever any update comes, it will get updated on the client side as well. So just important to remember, this function is called right after this /get. So it will not be really visible in logs, but if you actually follow the date, you'll see that here we have like 19.33, and here this one is also here. So you see that it's right after the first request. You have 19 point something. This is the get, and then the clicks are 25, 26. This is because by default reach logging is happening, that on the bottom of the screen you see currently open connection, so we don't have to scroll it, because that will be the connection that you in most cases care about, because this is where most of the information most of the things can go wrong, basically. Okay, so let's go through the method itself. So what we are doing basically is that we are reading signals from this request, because they are attached by Datastar. One of the values from this signal will be the user ID that the user uses. If it doesn't match, we just redirect back. We're not really going into validation as of this video, but basically we're getting this user ID that we set in the main request. Here we'll just add that user back to the list of users that we have online. We will publish using relay. We'll publish an event to all listeners that someone joined, and then we will do those logging stuff here. So just going back to logging here, you see that we are emitting here an event. So the curly brackets, rounded brackets are issue an event. So we can see here, this is the one. So we see that from the moment of the beginning of the request till on join request were issued lasted like 35 milliseconds. And like this is the user that joined, etc. And here we have square brackets. So this is the attribute for the main span that we have. So this will be this one. Really quickly and really generally speaking, relay. I wasn't really explaining it yet, but for the general purpose of it is that you'll probably notice that there's a common way of building applications in Datastar that kind of emerges if you like synchronize all the possible ways and how stuff actually work. And the idea is that you have this one long-lived connection, and you have, like, if you want to signal that is something happening in the application, you basically issue really short requests, for example, like a post on a click or like on scroll, whatever. And the whole idea is that you have those, let's call it, two connections. So one is incoming to the user, one is outgoing to the user, like incoming from the user and going to the user. And we need to have some way to sync those two, right? So if we want to send updates to the user, we need to have some kind of message bus from the event emitting party to the event listening party. So the relay is just that. One can send an update, in another place you can listen for those updates on some topics, etc. So this is just this idea. And then when we have everything set up, so we have user that joined, for the user that just connected, we are sending them the first patch with the current state of the game. So basically, this is like using Datastar to patch the HTML with the current state. So just important to remember, like, before, the earlier request was like with that user not yet in the game, so that user was not yet added to the list of the users. And in this request, they will be added. And so the state will be different. So for example, the list of users will be different. So that will show that they actually joined the game. And we have yet another event, onload patch, and this is this one. So this is like useful, not useful, depending on your use case, that you can see like what are the delays between certain operations, right? What is happening here is we are using this w.alive function, context manager, that is also able to encapsulate like a streaming generators. So it might be a little bit hard to understand at first, but if you actually look closer, not this one. If you actually read it slowly, it will be just understandable. So we have, let's start from this one. So here we are just subscribing for the relay events that are happening. So we are subscribing to anything that happens anywhere. And relay itself would return us the the event that was emitted, and then the payload that was there. So in our case, we have we will have an event and the user ID that it relates to. That's like really simple. We can make it more complex, but for our cases, this is all we need. And this w.alive, what it's doing, it's not changing the signature of what is returned by subscription. It's just ensuring that we are doing it as long as user is alive, as long as user is connected to the server. And also, we can still parameterize it, but alive is also ensuring that if the server shutdown happens, for example, during development, it will also close the connection. So it's really useful if you think about like a rapid development cycle. So you can open the page, and if I just Control-C on the server, it will make sure that it's like from the client perspective, it's visible just as a disconnect. And then they will try to reconnect again, and they'll get a new updated version of the HTML code, whatever there is. So inside it, we are, as probably imagined, we are logging that something happened, and then we are yet again patching. So we are just sending the update to the user with the current state of the application. So it's important to kind of think about it that we have those two avenues, those two roads that the stuff are happening. So I haven't really talked about clicking and the click method, the click handler yet, but you can probably imagine that in that one, when user clicks something, we need to update the board itself, right? And then send updates. And in this one, when we actually listen to the changes, we already have them. So the only thing needed for the user, the only thing left for us, is just to render the state for the user. And there's also like a whole different discussion that we can have here, or like the whole different avenue and like topics that we can discuss. But for now, just for the simplicity, this is like per user state. So you can imagine that different users will see different things. So for example, like if I'm a red user, so like with red color, it will render for me the whole HTML with that one box being red, right? So, but if every user sees exactly the same thing, you can like have it optimized by just rendering it once and sending it to all users at that moment. So yeah, so as long as connection is alive, this is happening. But when the connection closes, the handler still has time to actually execute stuff. And it's up to the handler to conclude its execution. That's really important distinction between Stario and other frameworks, because not all frameworks approach this connection the same way. That's at least my experience. In some, you have to watch for it explicitly. In others, if you have streaming responses, they will last as long as the connection is active, so you will not really, like the iterator, the generator that you return will not be called if it's disconnected, so we don't really have easy way of handling disconnects. But here, the whole idea is that we split the timeline of handler from the timeline of the connection. And yes, in 99% of the cases, they should follow each other. So the handler should closely monitor if the connection was not closed. But in our case, and especially if we know what we're doing, we can just approach it, like use and leverage it to our advantage. So in our case, as long as user is active, we know we should send updates to them. But once they are disconnected, it doesn't make sense to send any updates to them because the connection is broken, but we can still update the state of the game so that other users will know about it, right? So this is exactly what is happening here. So right after the disconnect, we remove the user, we publish the new event, we publish the event, the logging that someone left, and close it. So that's where this kind of structuring with the writer instead of returning the new function if the generator, like you would in other frameworks, this is where it's much simpler and cleaner in terms of like following the logic, following the timeline of what is expected to happen. So let's take a look at the last handler. Let's take a look at click. So this is just a post request that is happening. And yet again, what is happening is we're using this C signals. I haven't really explained it in the board earlier, but this is just a convenience method that we can use to read signals in a selected schema, let's call it. So we have home signal class, data class, that if we provide two signals, this helper will try to parse incoming signals from Datastar as this class. So here we'll have it available, like with user ID and any other thing that is defined here. So yet again, if the parsing fails, we redirect back because we don't really care about validation in this scenario. But then we also have another argument that comes from the request directly. So we're interested in the cell ID that was clicked. So we just get it from query parameters. Here we are parsing it as an int, adding some attributes to the request itself, so we can see it here. Let's take a look at any of the posts here. So we can see that it's post, click, 204 response, and the cell ID and user ID that clicked. So that's about right. And now an interesting part that is actually happening. It's not really that important in this case, in this scope of the application, but you can probably already recognize the thing that we see here from other frameworks. So namely, we don't like using the writer and this way of handling connection. We don't really have a need to have a separate concept of background tasks, because at that moment in this line, we send an empty response to the client, and from connection perspective, we are disconnected. So anything that happens here is in the background. So we can do some heavy computation. I wouldn't really advise it, but we can do some database operations or like call some APIs, etc. From user perspective, it was perfect. Like it was like clean response. They have they have their handling back, and they're happy. So what we're doing here in the background is we are basically processing it. So the really nice idea, the really nice concept that you'll kind of see emerging is that if we can do it this way, so in Stario 1.0, I call this detached command, but here we can just do it explicitly. So the idea is we have a request incoming, we validate it. It doesn't really mean that we can process it yet, but we are just validating if that makes sense. So if the signature is there or if the arguments are there, and then send to the client, okay, we are good to go. Just go ahead, do your stuff, and we will do our stuff. And then in the background, we're actually processing it. So we are like checking if they actually can do it. Maybe someone else did something in the meantime. We don't really know. And then if they actually were able to like do it, right? So if the actual command succeeded, then we can just publish the change. And that's like what's everyone is interested in anyway, right? So that's about it when it comes to handlers. That's like a lot of stuff. But at the same time, I hope that just going through handlers kind of gave you the idea of why we approach stuff the way we do and why it works. We have those three main ways of responding. So we have this quick response, very usual, like nothing extraordinary. We have this long-lived connection that is mostly in the Datastar relation. It's mostly about updating the user. So we have this clean life cycle of doing stuff before the connection, like at the beginning of connection, while connected, and after they disconnect. And then we have this third type of handler, this third kind of behavior that is commonly used, is that we want to validate and respond, but only after the response we want to handle in terms of like doing some heavier computation, inserts, calls, etc. So we've talked about the Stario application and router overall. We talked about handlers and how they work. Let's briefly take a look at how we generate HTML in Stario, because this will be, so the HTML is a language of the web, as the H in all the HTTP or HTML. We have a particular approach to it. It's not really like any different in any, like maybe commonly known libraries for HTML generation in Python, but there are some subtleties that I introduced here, and I think they work nicely. So we have what we have is that we have a whole Stario.html module that is just responsible for allowing you to use tags, HTML tags, to compose HTML objects, or like the components, however you call them. So we have like stuff like HTML, head, meta, etc. For the purposes of just getting around some of the collisions, they are just uppercase names. So the first letter is uppercase, but all the names, etc., they are exactly the same as you would expect. So like HTML, head, div, img, etc. So this is all the same. And the main idea of the HTML is that this is basically, like, if you go into details, this is just a function that actually is happening here. But and this is like how we compose stuff. But this is not a moment that we'll go talk about internals. It's more about like how to use them and why you should use them the way I'm kind of today here outlining and trying to convince you to do. So as you probably know, HTML elements, like, they have their name, so like a tag name, they can have attributes in them, so in the tag, and then they can have children. So the natural way, at least for me, from my perspective, to structure them and like show them in Python is that we have a function that corresponds to the tag name. Then we have attributes as dictionaries. So that's like any arbitrary key value that will be inserted here. And then we have, we can also insert children in it. The order doesn't really matter. Like in terms of the HTML children, they will be in the order they are defined, but I can also define attributes here at the very bottom, and they will be added to the HTML itself. So here we have HTML with lang, meta with charset, title. Let's take a look at what might be a little bit unusual and draw your attention here. So, as I mentioned, we have a very peculiar way of handling static files. Oh, where am I? Of handling of static files in Stario. So the way it works is we don't really call them static assets or like static files. I tend to call them just assets because it shows the relationship of what we like, how we should treat it more or less. So this is just something that we want to use, and that is not really like a resource itself. It's just an asset to be used by someone else, right? So what is happening when we mount them, when we have this directory with JavaScript or styles or any other thing or any images, on startup, on the moment that we mount them, we create those fingerprints. So creating a fingerprint means that the name that we see in the directory, so for example, the css/style.css, it will no longer be that, if you think about it, right? Because it will be css style.abc123. This is this case here. So what we're doing is that we surface this convenience method, this convenience function that you can call anywhere. And the idea is that you can just call it, provide the name of the asset that you would use as usual, and the framework itself will resolve it to correct fingerprinted version. So that's just a convenience method, so that you wouldn't have to like hand lock it or like create some strange files that map it, etc. So that's how it works. Let's now take a look at other stuff that is happening here. So here we have, this is the main page. We see that we insert some children here just as an unpacking. We have a cell view. So this is just returning the div of that particular cell, and we can parameterize it. What's interesting here is that, as I mentioned, all the attributes are passed as dictionaries. So we can pass here just a class and then a string, but also we can pass it as a list here. That would also work. And it would be just concatenated with a space in it. So that's like useful in terms of like rapid development if you want to comment some lines out and in, etc. So that's how it works. Then we have two things that, so okay, one is showed here, but also the other two I will mention. So in attributes, we have really commonly used like style attributes and also data and area attributes. So because they are commonly used and maybe not always like treating them and writing explicitly, like parsing the style explicitly is a nice way. So this is why you can use dictionary notation for them as well. So for example, in style, all you have to do is to provide the style and in it the dictionary, so the background color and this color provided here, it will be nicely concatenated with this as a, oh, I messed it up again. It will be just nicely concatenated as it's outlined here. The same thing goes for data and aria. So the way it works is if you define data directory and go in here, they will be just concatenated. So the key in data, for example, let's do it on click. It's an old notation, but doesn't really matter. Or maybe let's just do some attributes. So what would happen after you render it is that you would get data minus my attribute, my minus attribute, and then that would be the value assigned. So it's also like useful if you don't want to have like too much of the repetition and you kind of want to build the data object and just pass it in. That's about it when it comes to HTML itself. So we have like the general idea is that you basically, so all HTML tags are functions. They expect you to provide dictionaries that define the attributes for that HTML object. And also if you provide other HTML objects as an argument to it, they will be treated as a children. So that's how you basically build all of it. So that you have a div, if you want another div in it, you just pass it in. If you want to style it in any way, you just create a dictionary with like a class or style or anything that you, or like just an ID and you style it from outside. That's also perfectly doable. So in here, when we think about board view, so this is this main board view that just renders the board itself based on like our global board set that we have. What we're doing here as well is that what I want to like pay attention right here and kind of showcase as well. So as of this moment, we know that we can create handlers, we can create HTML, it will get rendered nicely, etc. But I'm talking in some places here. I mentioned that we need to remember that it's all Datastar related or like Datastar dependent, because we're using it as this front-end library for like on the front end on the browser to allow us for patching, for signal propagation, etc. So in Stario, we have data attribute, data variable, let's call it. This allows us to build all the Datastar related attributes. So technically speaking, from technical perspective, this is just a class with like lots of methods. They are the same as if you went here to Datastar and went to a reference. So all the attributes listed here, I think without the pro attributes, but all the attributes listed here, let's call, for example, the effect, maybe or like an attribute, it's just a function there. It's just an available method. So data dot, and then you can use it. So for example, in here, we're creating we're adding a data attribute that subscribes to onClick method, like listed here, and that would be the expression that is executed when that happens, right? So the idea is that in this case, just to explain what is actually happening, is that we have this single div. In it, we have all the rows and columns of the board. And when someone clicks in them, so we're listening to this on click, the click will surface up to this board. and we just have one place where we actually do a request. So this one, when we actually do a post request to click itself, and we pass this ID of the cell that was clicked. So that's more of a trick for this purpose of this video. But basically, what I wanted to show you is that we have data. Data allows you to build all the actually, it should be this one. Allows you to build all the attributes related to Datastar. Also, we have add attribute that allows us to build all the actions that start with add. So, for example, this one, like add peak, add set all, add get. And let's maybe take a look if we have it here. Okay, so we have. So if we go into the home view and take a look at what is actually happening here. So this is like the main page, like let's call it like level above the board itself. So this is where we have we are using data.signal. So we're defining a signal on the front end that will hold this user ID. And we are defining it only if it's missing, because it might have already been set in a previous refresh. And then what we're doing here is when we initialize this object, so when it's first loaded, we are using this add get. So we are basically opening a connection to /subscribe on our server. And in here, we're just creating some of the objects to make it look nice with the info panel, with board view, and we also use this toy inspector. So maybe just as an example, maybe just as a add-on, let's call it, we have this toy inspector that I've added, and it's fairly useful for development, not really for the production. I would just comment it out if we're depending on the environment that we're using. So the idea is that if you look closer here to the example, here we have this draggable, maybe doesn't really work the best, it could, but this is just a simple inspector that shows us available signals that we currently have. So just to kind of connect all the dots that we've been talking about. So we open the page, the incoming request sets, just talking about it here, incoming request sets the signal to our user ID that we've generated. Then with that generated ID, we open the SSE connection to /subscribe. That /subscribe is the main route that handles the lifecycle of the user. So like the adding them, listening to updates, and then discarding them. And each one of the clicks is just a simple, really quick post request that when we handle, and if it's correct, then we just, using relay, signal back to this /subscribe to all connected users at the same time. Okay, so I think that's mostly it. I hope that it was useful. I know it's a lot. It will be fairly long video to go through, but maybe just to wrap up, just to have it as a summary here and kind of repeat what we've went through and how stuff works. There's a lot of really cool other stuff that we can build using it, and all the from my perspective, Stario is not really that interesting. So just the framework itself. What's actually more interesting is how all the pieces kind of work together. So it's much more interesting to talk about and talk based on examples and samples of usage than to talk about just how it works and the possibilities and the all the attributes, all the classes, all the methods that we have in Stario. That's from my end, that's not at all interesting. What's interesting are the applications, are the actual the actual usage of it. So let's quickly go through what we went over this video again. So just to wrap up. So we create and start up and set up and configure the application ourselves. That's our responsibility. We do it however we see fit. We can do it in code. We can surface them as a CLI methods. We can do them from environment variables, whatever we set here. Whatever we need as an argument, we do it ourselves. That's pretty straightforward. Then we create a tracer. So we need tracer so that we know what is happening in the application. By default, we have this RichTracer for the local development, and we can also use JsonTracer for like production release if we could just care about the code output itself, the what's happening itself. Then we can just put it into Grafana, whatever else. Then we create an application itself, or like set of routers, and routers can be mounted into the application. But basically, we create an application. In the application, we mount handlers on particular paths and routes. Once that's done, the only thing left is to serve the application. Going through the handlers, we have this peculiar signature that is different than in most widely used frameworks. It resembles a little bit ASGI or like WSGI interfaces, but I hope you understand that it's not just that, it's a little bit more than that. We have context that is all about what is incoming and like what we can work with, basically. And we have writer, so that's our connection and understanding to what is happening connection-wise and what we can send and how we send it. We have in the context object, we can access request, we can access logging, so the span, or like use it through either directly, so c.span and then call methods on it, or we can use this context convenience method like square brackets or like the rounded brackets, and they will add attributes or add separate events directly. Then we have writer methods. We can send response at once, so this will be like this w.html, or we can stream them over time, so it will be this w.patch. Let's quickly take a look here. So that's there. One of the really convenient method, but you don't really have to use it if you don't want, is this alive context manager. So as I mentioned, as I explained, this is the context manager that sole responsibility is to watch for disconnects or servers shutdowns. So whenever that happens, we can react. So in 90% of the cases, at least from my experience, we can treat both server shutdown and client disconnect the same way. And both of those should be like reacted immediately. In most cases, it's just like the status update that client disconnected, and that's it. So what's nice about it in terms of like this, the overall syntax and happening, is that we have this really, let's go back here. We have this simple context manager. We don't really have to do some like try except and expect some cancellation errors, etc. So this is happening kind of internally here, but we are ensured from the framework perspective that if they disconnect, just anything that is happening inside here will get paused. So like it will no longer execute. It will, if it's a loop here, if we have async for, it will stop iterating, and we will come here and do some cleanup stuff or other things that we implemented. Last pattern that we can also observe here is this, let's call it background task. So we do background tasks in Stario ourselves, basically, and we can do them however we see fit. It's that in most cases, like if we think about like the command pattern, is that you would want to validate the request and then like just give the user info, okay, I'm handling it, go away. And then we do it like on our end whenever we want it. So instead of, as it would be in Fast API or Sonic, instead of like creating a function as a background task and then waiting for the framework to call it, we have full control here. No nesting, no handing over somewhere some functions or creating some closures. Nothing of such sort here. It's just everything is explicitly stated. That's really, really nice and really convenient. I think that in terms of HTML, it's just worth to underline again. We can build components, we can build HTML objects. We have Stario.html module from which you can just import all the HTML tags that you want. HTML attributes of a tag are just modeled as dictionaries. You just pass them in. You can pass multiple dictionaries. That's also fine. They will just get concatenated. And then you have, if you want to do child nesting, so if you want to have certain attributes as a children of it, you just pass them as an argument to this function. For static assets, we have this asset function that is a global function. You don't really need to pass context anywhere here. It might be a bad design choice, maybe, but it's fairly useful and make things relatively simple. And then we have data attributes. So Datastar related generation. So we have data dot and then all the methods that are from Datastar. Or we have add dot, and those are all the actions from Datastar that we can also build and use. So in our case, we're using here data on to subscribe to click method. But also if we look closer here, we have data.init. So this is what happens when we initially load this object, or data.signals. So basically we're setting the signals for user. I think it's a lot. I think it's a fairly nice rundown through the project and the Stario philosophies and solutions overall. So I hope that will be useful and you'll find it at least informative. Maybe it will spark some thinking on your end. Maybe like I'm not here to convince you that Stario is the best. I'm just trying to convince you that there are ways of thinking about problems that make certain solutions a little bit easier. So that's how Stario came about. It was never about like trying to enforce my kind of thinking. It was more of that, at least from my experience, something like that was missing from Python ecosystem. So my hope is that it will fill that void a little bit. Thank you, and see you soon. Bye.